11.1 is composites. That's when you stick, I'm just sharpening my pencil here. That's when you stick one function into another function. So for instance, I define two functions at the top, f and g. Now let's say I want to find f composite g of x. That little Cheerio looking symbol means composite, which means you're going to stuff g into f. So let me rewrite that as f g of x. It's a little easier to see in that. It's a different format, but it means the same thing. So what that means is where the x is in f, you're going to stick the g function. So you're going to take all of g and stick it in the x, in the f function. So you can start to rewrite this by saying g equals x plus 4. So you're now going to do f of x plus 4 versus doing f of x. So you take the f function, which is 2x minus 5, and where the x is, that's where you stick the g, which is x plus 4. And everything you did to x, you now do to x plus 4. So you get 2x plus 3. All right, now if we do it the other way, for instance, if we do g composite f, that would mean now we're sticking f into g. Let me just fix that. So now where the x is in the g function, we would plug in the f. Okay, so f, the definition of f is 2x minus 5. So that means that instead of doing g of x, you're going to do g of 2x minus 5. So we take the g function is x plus 4, and where the x used to be, we plug in 2x minus 5. So 2x minus 5 plus 4, you combine like terms, you get 2x minus 1. Now, just a side note here, sometimes you're not given an x, you're actually given a variable, a constant, say like a 2, like x is 2. There's two ways to do that. So the first way would be to just plug it in each layer. So for instance, I would start by finding f of 2. So my f function is, again, hold on, let me write it generically first. 2x minus 5. So if f of 2 would mean that x becomes 2. So that's 4 minus 5 or negative 1. So the g would, so f of 2 would output a negative 1, and then I would put negative 1 into the g function. G again is x plus 4. So g of negative 1 would be negative 1 plus 4, which would be 3. So this would equal to 3. So sometimes you're actually going to give, instead of just having an x, they're actually going to define what x is. And if you do that, you actually have to crunch it in and plug out the numbers. So if you start with a number, you're going to end with a number. If you start with an x, you're going to end with an x. So if they give you a number, there's two ways to do it. You can plug it in just like I did, or you could take the composite first, which we already found, and after you do the composite, you can actually plug in the value for x into the final composite. And you'll notice you'll get the same answer. So there's two ways to do it if it has a number, okay? All right, that's it on composites. In the next video, you'll work on the inverses. Catch you.